Okay, we're going to take a look at problem 11 in the chapter 6 assignment. And this is about restaurants, and nobody likes to wait for their service at restaurants. So supposedly Wendy's has an average service time of 2.2 minutes. And that's less than all their major competitors back in 2014. Assume that the service time for Wendy's has an exponential distribution. Exponential distributions are often used to determine the probability for wait time situations. So first, we want to know what's the probability that the service time is less than or equal to 1 minute. We want that to 4 decimal places. Next, the probability that the service time is between 30 seconds and 1 minute. Again, to 4 decimal places. And if you're doing this by hand, they make a point of telling you not to round the intermediate calculations, because exponential distribution calculations are very sensitive to the magnitude of the decimal places that you use in the intermediate calculations. And then next, we want to know what's the probability that your wait time will be greater than 5 minutes. If that's the case, your food's going to be free. So those are the 3 probabilities they want to ask. And lastly, they tell you that this box is not graded, but may be reviewed by the instructor. Well, guess what? I'm not going to review it. You just have to get these right. So for these types of problems, again, you can use your calculator if you like. And I've opened up the textbook so you can see the exponential probability distribution function. And as you can see, it only has 2 inputs, that average value and the x value. And you'd have to use the value for E, which as you can see here is 2.71828. So with that, you can calculate the probability for any given value of x. If you have an interval, then you'll have to calculate 2 values. And that's fine, but again, in modern day work, you use Excel or some other automated function. Of course, you have the exponential distribution function built in to your calculator if you have an advanced function calculator. So let's just use our statistical toolkit in the interest of time. So if you open up the statistical toolkit, your exponential distribution function may be showing here. So as you can see, I've laid this out so that we have the mean and the x value as inputs. Our mean is 2.2 minutes. We want to know the probability of x being 1 minute or less. So the probability that x is less than or equal to 1 is 0.3653. I'll actually enlarge this a little bit more. I also have it calculating the probability that x is greater than or equal to some value. You can see the function here that I use for that. So to determine the probability of the wait time being between 1 minute and 30 seconds, we use the section of the tool that has probability within an interval, type in the mean, and the lower value, 30 seconds, is simply half a minute. So you would use 0.5 to maintain the proper units. And the upper value would be 1, which would give you a probability of 0.16197, rounded to 4 decimal places. That's going to be 0.1620. So then lastly, we wanted to know what's the probability that the wait time will be greater than 5 minutes. So we can use 5 here as our x, and the probability that it's greater than or equal to 5.10303. Now you might be thinking to yourself, wait a minute, we said we wanted to know the probability of the wait time being greater than 5, not greater than or equal to 5. That was important when we were doing discrete probabilities. But when we're looking at continuous probability functions, one of the things you have to remember is that there really is no difference in saying the probability greater than or equal to 5 and greater than 5. Because as we recall from our calculus, the probability at any particular point is going to be 0. The area under the curve at any particular point is going to be 0. So there really is no difference in saying the probability that x is greater than or equal to 5 and simply saying the probability that x is greater than 5. So this is the probability you would have for either one of those statements. So switching back to the problem, I've entered these in, and as you can see, they all check out as being correct.